What is DART and why was it important? In this video, we will explain what NASA is up to these days. So watch this video till the end so you don't miss anything. And at the end of the video, we'll also share the latest happenings of this mission and whether it was successful or not. So let's start. But first, don't forget to like the video and subscribe. We wouldn't want you to miss out on any of our upcoming content. Firstly, what do you need to know about DART? NASA's Double Asteroid Redirection Test, DART mission, was essentially to test a kinetic impactor mechanism for deflecting asteroids for the sole purpose of planetary defense. According to NASA, DART hit the tiny asteroid Dimorphos to slightly alter the orbital speed of the moonlet. The ambitious mission imitates what NASA scientists would do if an asteroid were traveling toward Earth, even though Dimorphos does not represent a threat to the planet. On September 26, 2022, around 7:14 p.m. EDT, 23:14 GMT, there was a collision. Back on November 23, 2021, at 10:20 p.m. local time, 1:20 a.m. EDT, or 6:20 a.m. GMT, November 24th, a SpaceX Falcon 9 rocket was used to launch the DART mission from Space Launch Complex 4 at the Vandenberg Space Force Base in California. The mission is an example of the intense international cooperation required for such a challenging task. Although the Johns Hopkins University Applied Physics Laboratory, JHU-APL, oversees the DART project, scientists and engineers worldwide have teamed together to participate. Up next, why is the mission important? Even though there is a minimal threat from asteroid impacts, we should be ready in case one does occur. To understand the disastrous implications an effect can have on life on Earth, we need to consider historical events like the enormous Chicxulub asteroid impact, which is blamed for the extinction of the dinosaurs 65 million years ago. According to NASA scientists, there is a slight, but there is the actual possibility that an asteroid might tragically strike Earth. NASA often scans the skies in search of new asteroids and has discovered around 40% of those that potentially threaten Earth and are as wide as 500 feet, 140 meters. NASA's brand new space telescope Sentinel, called the Near-Earth Object Surveyor, was made specifically to check for potentially hazardous asteroids in the solar system. That mission might start in 2026. Early near-Earth asteroid discovery is the first stage in planetary defense. At the start of 2019, there were more than 19,000 freshly detected near-Earth asteroids, and on average, 30 new ones are found every week, according to NASA. So, what is the goal of the mission? Greek for twin, Didymos is a binary asteroid system that was the subject of DART. The system consists of the moon Dimorphos, which is 525 feet, 160 meters across, and the near-Earth asteroid Didymos, which is 0.48 miles, 780 meters across. DART struck the moonlet Dimorphos at a speed of more than 23,750 kilometers per hour. That is a staggering 14,760 miles per hour. The moonlet's orbital speed should have changed by a small percentage due to an impact at this speed. This change should be sufficient to alter the moonlet's orbital period by several minutes. NASA claims that to determine whether the mission was successful, telescopes on Earth watched and measured the alteration in Dimorphos' orbit around Didymos. Dimorphos' approximately 12-hour rotation was reduced by a startling 32 minutes thanks to DART, according to an official announcement from NASA on October 11, 2022, defying earlier predictions. Nancy Chabot, a planetary science from JHU-APL, discussed the mission plan with How It Works magazine, a sister product of Space.com. Targeting a small asteroid in space at a fast rate of speed when that asteroid has never been observed by a spacecraft before is one of the mission's critical technological hurdles, according to Chabot. The characteristics of other asteroids that have been investigated, including their variety of shapes, interior structures, surface qualities, and strengths, will affect how much the asteroid Dimorphos is deflected in its orbit around Didymos. Up next, what is the impact from DART's collision? The first planetary defense test ever carried out, according to the American Space Agency, was DART's successful collision with Dimorphos on September 26th at 7:14 p.m. EDT, 23:14 GMT. Despite the on-target collision, there was a mix mixture of calm and suspense at the DART Mission Control Center at JHU-APL as the spacecraft hurried toward its doom. The 21 possible backup plans that engineers had developed in case the crash didn't go as planned did not need to be tested. DART's final 4 hours were mostly automatic, with the navigation system of the spacecraft locking on to Dimorphos in the penultimate hour of approach. DART's primary camera sent an image to Earth every second up until the transmission went dark as the spacecraft smashed into the asteroid. Didymos and Dimorphos were captured in exquisite clarity in photographs obtained by the spacecraft during DART's final moments. It was the first time seeing the moonlet. DART recognized it as a strange new world, an asteroid with an egg-like form and a rough surface. So, did DART have any companions? According to NASA, the DART spacecraft was not alone in its trek to the near-Earth asteroid pair, since it was accompanied by LICIACube, light Italian CubeSat for imaging asteroids. The Italian Space Agency and the Italian aerospace engineering firm Argotec collaborated on constructing LICIACube, a CubeSat. The tiny CubeSat is about the size of an adult's hand and forearm, weighing about 31 pounds, 14 kilograms. It is equipped with 2 optical cameras, tracked DART to Dimorphos, and then settled in to see the crash from a safe distance of around 600 miles, 1,000 kilometers. The purpose of LICIACube was to monitor the effect to determine whether the experiment was successful. The LICIACube's mission's co-investigator, Mazzotta Epifani, an astronomer at Italy's National Institute for Astrophysics, INAF, told Space.com in an email, LICIACube will perform a fast flyby around 3 minutes after DART impacts at a minimum distance of about 55 kilometers, 34 miles from Dimorphos. The target impact and non-impact size, as well as the plume formed by the DART hit, will be the focus of the 2 onboard cameras' practically continuous image acquisition for roughly 10 minutes. The photographs will subsequently be sent to Earth by LICIACube. However, as Mazzotta Epifani cautioned, it could take weeks to download all the data. Coming right up, who created and oversaw the mission? The Johns Hopkins University Applied Physics Laboratory created and oversaw the DART mission for NASA. The DART mission is sponsored by NASA's Planetary Defense Coordination Office, which controls planetary defense operations. Up next, was the mission popular? Other spacecraft joined LICIACube in watching the DART asteroid collision, including NASA's new James Webb Space Telescope, the Hubble Space Telescope, and the Lucy spacecraft on its own asteroid mission. These spacecraft watched the collision from their respective vantage points throughout the solar system. On Earth, more than 30 telescopes were trained to track the binary Didymos-Dimorphos system, with at least one on each continent, to determine how much quicker Dimorphos is presently traveling in its orbit and whether the redirection test was practical. They are now prepared to study the couple for 6 months. So what happens next? The European Space Agency, ESA, is planning the Hera post-impact investigation mission. According to the mission website, the spacecraft is scheduled to launch in October 2024 and arrive at the Didymos binary system in December 2026. 2 CubeSats are to join ESA's Hera spacecraft. Both Didymos and Dimorphos are to be surveyed by 2, with particular attention paid to the crater caused by DART's crash with Dimorphos. According to JHU-APL, the Hera mission also seeks to establish the precise mass of Dimorphos. Though the 2 projects, DART and Hera, are created and run separately, they will improve our knowledge of planetary defense systems when combined. AIDA, Asteroid Impact and Deflection Assessment, is an international partnership with team members from both missions. AIDA, according to ESA, is a significant multinational partnership involving NASA, the Observatoire de la Côte d'Azur, OCA, the German Aerospace Center, DLR, and the Johns Hopkins University Applied Physics Laboratory, JHU-APL. According to Chabot, DART is only a small component of a more comprehensive planetary defense strategy coordinated by NASA's Planetary Defense Coordination Office. According to her, the technology's demonstration by DART will be an important result to inform future planetary defense actions. Finding, tracking, and characterizing the population of near-Earth objects is essential to the effectiveness of any planetary defense mitigation efforts in the future, of which DART is merely the first trial. Lastly, what's the latest news from the mission? And the latest news is that the Double Asteroid Redirection Test, DART, mission, run by NASA, successfully modified the orbit of an asteroid millions of miles distant. The agency reported on Tuesday Tuesday, October 11th. The following analysis over the past 2 weeks since the spacecraft struck Dimorphos, scientists discovered that the kinetic impact had shortened the moonlet's orbit around its parent asteroid Didymos by 32 minutes. This was the first time humanity had purposely altered the motion of a celestial object and the first full-scale demonstration of asteroid deflection technology. Dimorphos used to orbit Didymos in 11 hours and 55 minutes. The measurement has a plus or minus 2-minute range of uncertainty. And this brings us to the end of the video. We hope you gathered some information about NASA's DART mission. Please share your views on it in the comments section below and subscribe to the channel to stay updated with upcoming exciting videos. Stay tuned for more. Bye!